Wait a minute, I'm going to turn off the okay. So I'm a medical doctor by training, and of course I am from Myanmar, and I finished my medical degree in 2012, and right now I'm doing my PhD at the Prince of Songkhla University in Thailand. So I'm a medical background, from medical background. So for the whole course, I'm going to give example using medical studies. So if you are unclear or if you want to ask questions, you can do freely. So before we continue, I would like to say that this session will be every day from 7 p.m. Bhutan time, okay? And supposedly it will end on 8 p.m. But anyway, we will see how it goes. And so this session will be on the evening every day, so you can join for a starting session. If a starting session is familiar with you, and you can skip this session and join on the next session. It's all right. And anyway, this is rather free, so I think anyone can join and skip the session on your experience, okay? So there is no strict rules to learn in this. But anyway, if you have any questions or if you want to ask any questions, just unmute your microphone and just interrupt me, okay? So let's start with this. So the first thing I want to do is to say that I do not own all these contents, and I modify some contents from this online course, Duke University, with a specialization course. Name statistics with R, the same name. So I modify this content for educational purpose only. And all the credits go to Min, Sintikaya, Randall, and her teams. And it is a very popular Coursera course provided by the Duke University. So I suggest you look at their course as well. But anyhow, this is not exactly follow the course provided by the Duke University. Next is I aim for 4 weeks to finish this course. And the first weeks we will talk about how we should understand data, how we try to understand data. And the second week we will explore the relationship between variables in our data. And for the third week we will try to look at a more complicated relationship between your data called linear regression. And the fourth week, we will look at the same relationship between different variables and using logistic regression. So along the course, I will explain what kind of statistics are there and when conditions to use this kind of regression methods. So essentially, it is like a very basic statistic course with certainly 2 components. And the 2 most commonly used methods, linear regression and logistic regression in statistics. And the objective of this course is when you get your data, or when you read an online article, a paper, whatever it is, trying to see what kind of data you have and what kind of biases there can be and what kind of association are you going to show, or what are they describing, and how strong the evidence of that relationship. So essentially we will explore around these contents. in our course. So supposedly I'm planning to have 4 weeks, but it will take less than that, and we will see how it goes. And one of the, I think one of the important features from this course is we will do hands-on analysis using R software. So we can also talk about R tomorrow or the day after tomorrow, and how to install this in our computer. Okay, any questions up to this? Hello, everyone. Any questions?
No questions.
Okay, now.
You can continue, sir. You can continue, sir.
Okay. Okay. Anyway, let me know if I am talking very quick or if you don't understand what I'm saying. Okay, let's start with this week, understanding data. So we will start with this picture. This is a smoking study. So there are a lot of smoking research study early in the US, early 1930s, and there are a lot of there are a lot of evidence suggesting that smoking is harmful to our health. But in earlier days, they did not know. So it's like even in this day, like in say certain developing countries or in certain areas, like someone may say to you as his doctor, say, doctors, my uncle smokes 3 packs a day. He is perfectly healthy. Okay, so that kind of thing is called anecdotal evidence. It is evidence, but it's not just scientific. It's called anecdotal evidence. Okay, so what does it depend? What does this kind of evidence based on? It is based on my uncle, right? Your uncle or someone's uncle. It's based on only one or a few person. So in 2009, the Secret Sanctuary, they said that smoking is a very complex human behavior, and by its nature, it is very difficult to study, and also confounded by human variability. So that's why your uncle smokes maybe 12 packs a day, and he is perfectly healthy. Say someone's uncle had been, smoking for his life, and he is still, make up past 70 years of age. So, but we will say that this kind of evidence is not scientific. The data collection process is not scientifically conducted. So what is important here is your population. How many people or what kind of people do your conclusion come from, right? So we will look at another study. It's like here we will look at alcohol brand use and injury in the emergency department. So say that there are different brands of alcohol in your country, in my country. So say if someone drinks a certain brand of alcohol, and then maybe what we want to know is he more likely to get injured and end up in the emergency department? Okay, so that is what we are going to explore.
Huh?
Sorry, is that a question? Hello, is that a question?
I don't think so. You can continue.
Okay. Okay, so we have clearly said that population and samples are important, and we will further elaborate this point. So our research question in this study is, are the consumer of a certain alcohol brand more likely to end up in the emergency rooms with the injury. So this is our research question. So who is our population?
Consumers.
Sorry? I didn't hear that. Who is our questions? Who is our population?
Consumers of drugs.
Whoever
All
drinks and comes.
whoever visiting the emergency room.
Yes, correct. You're all correct. Whoever drinks alcohol, right? So in this group, if you don't drink alcohol, then you are not part of the study. Okay, I'm suddenly a part of this study. Okay, so let's see. Okay, let's look at our population. Everyone, and everyone is very vague. Should be everyone who drinks alcohol. And then our sample. So we cannot get everyone, right? So even in Bhutan or even in Nepal, or even in Myanmar, we cannot get everyone who drinks alcohol. So we need to get a sample. So in this case, so this study took place in US, Baltimore City at the Johns Hopkins Hospital. So the sample is every ER patient who visit the emergency room at Johns Hopkins Hospital. So you see how population and sample are quite different, right? And then what we can generalize based on this sample. So we can only generalize to the resident of Baltimore, or even we cannot say that because Baltimore will be a big city. Baltimore City is a big city, so there will be 2 or 3 more big or tertiary hospital. So not everyone who lives in Baltimore will go to the Johns Hopkins Hospital. So maybe even we can only say that we can only generalize to the resident around Baltimore or even around the Johns Hopkins Hospital who will have easy access to the hospital. So that is how our population and sample are important. So the reason we are talking about is in statistics, we deal with data. But statistics starts from earlier of the research project. Here in our case, research question. So even we call it the same data variable, if the population and if the sample are different, and then our generalization will have a serious limitation. Okay, so any questions until now? Okay, so next we will discuss about observational and experimental studies. So we can generally separate studies into 2 categories. The first one is observational, and the second one is experiments. As the name suggests, you know, observations, we call it the data as it is. That means that we just observe them. We do not interfere with their treatment. So the result from this kind of studies only establish the association. So there are 2 more terms I want you to focus. The first one is retrospective, and second is prospective. So there are some confusion in the literature about retrospective and prospective. So retrospective just means that you use past data. So if you have hospital data and you can access to that data, and you did an analysis study based on that data, it is called a retrospective data. Prospective means you propose a study, you propose a data collection plan, and then you carry out this data collection process. So the data are coming during that study period. This is called prospective study. So next we will talk about experiments. So experiments is basically what we do is we randomly assign participants to different treatments, and so that basically the basic idea is we can establish causal connection. So let's talk about an study. Okay, let's compare observation and observational treatment studies and experiments. So we will look at workout. Okay, we will look at exercise and how much energy level they are using. So in observational study, we have a workout group. Okay, they are actively working out, and there is no, like us staying home, no workout. So there is no workout group. And then we calculate the average energy level they are consuming or they are producing. So we have two groups. We just look at, the workout group and the no workout group, and look at the average energy level. We do not interfere with anything. So this is called observational studies. We just observe them. In the experimental study, similarly, we have this black three guys walking out. And then what we do is we randomly assign, okay? So we have like around 30 patients in our Zoom call, in this video conference call. So we say that, okay, 15 people, I will randomly assign 15 people. And then I say, starting from tomorrow, you walk out. And another 15 people, I will say that you do not do anything. Stay in your bed, starting from tomorrow. So we got workout group and no workout group. And then we measure their average energy level. So that means that we purposefully assign the workout and non-workout group. So these are called the experiments. Okay, so let's look at the breakfast cereal keeps girls slim. Okay, so in the US or Western world, they eat cereal as breakfast. And then girls who ate breakfast of any type had a low average body mass index, a common obesity cause, than those who said they didn't. Okay, so in this study, we want to know if a girl eats cereal breakfast, then is she more likely to be slim? Okay, so this study is conducted by the Maryland Medical Research Institute with funding from the National Institute, NIH, and cereal maker General Mills. And then we will look at a larger NIH survey consisting of 2,379 girls in California, Maryland, and we will track them between the age of 9 and 19. So this is a survey with 2,000 plus girls, and then we ask them once a year what they have eaten during the previous 3 days. Okay, so what do you think? Is this an experiment or an observational study?
Observational.
It's observational, yeah.
Yep. Everyone's correct? It is observational study, right? We just observe how they progress. Okay, so there are 3 possible explanations why eating cereal breakfast keeps girls slim, or slim girls eat cereal breakfast, right? Okay, let's talk about 3 possible explanations. The first one is eating breakfast causes girls to be slimmer. Okay, so because you eat breakfast, you become slim. That is one concept. And second concept is because you are slim, you eat breakfast, you eat cereal breakfast. That is the second proposition. And the third one is there is another variable, and it is responsible for both eating cereal and keeping slim. Okay, so can you understand this point? So we are looking at whether eating breakfast causes slim, or whether being slim causes girls to eat breakfast, or there is another variable called confounding variable. We will talk about that later. that is responsible for girl to be slim or eat breakfast, like say going to gym. So if a girl is staying healthy, she will go to the gym every day, and then she will eat breakfast, cereal breakfast. So in reality, there may not be any relationship between eating cereal breakfast and being slim. And going to the gym actually cause both variable. So this is the kind of confounding or the kind of relationship we are going to explore in this course. Okay, so like I said, there are some external factors that can affect both eating cereal and keeping girls slim. It is called confounding variables. So what is confounding variables? It's an extraneous variable. It's an external variable, which we haven't considered in our causal relationship. And that affect both the explanatory and the response variable. And that makes it seem like there is a relationship between them. So it's like because of that confounding variable, we are finding a relationship that is not in reality. That is called confounding variable. Okay. So here there are two terminology. Okay. The first one is what is it? The first one is here, and the second one is here. So the response variable in our case is say for an original title, the response variable is the girl becomes slimmer. The explanatory variable is eating cereal. So as you can see that we have three scenarios, which means that we have three scenarios, which means that the response and the explanatory variables will change depending on our concept. Okay. Okay. Next. So if you will remember only one thing from today's sessions, then I will say this. I would say that you take this message home. Correlation does not imply causation. Okay, so when we do studies, when we conduct research study, we want to find out association, relationship between variables. We want to find out if A cause B or if C cause A, something like that. But depending on our study design and depending on our populations and sample, we can see that there is an association, which is another term for correlation, but it does not imply with causation. Okay, for example, a very simple example is like this. If you smoke, you will carry a cigarette lighter. Okay, so it doesn't mean that carrying a lighter is associated with lung cancer, because there is a correlation between carrying lighter and becoming lung cancer, because there is a smoking factor, right? Because you carry lighter, you smoke, and because you smoke, you may have lung cancer. So carrying lighter and the lung cancer may have a correlation or may have an association. It does not imply causation. So you should be very careful to say the word causation, correlation, and association. Okay. So any question up to this?
No.
Okay, gonna respond, so we will continue. So next we will talk about the sampling and source of bias. Okay, so here I will talk about doing census and doing a sampling. and we will explore the sources of bias, and we will also discuss about sampling methods. Okay, so if you want to include, if you want, there is a population and sample. So why don't we just consider everyone in our sample? So wouldn't it be better to just include everyone and sample in the entire population? Say, let's look at the whole Bhutanese, the whole people from Bhutan, or let's say everyone in Myanmar, let's say everyone in Nepal. Wouldn't it be better? So the reason we are, rarely doing census is that some individuals are very hard to locate or measure. Like us, we migrate all the time, right? Well, we came to Thailand and we go back to Myanmar and stay a few days and then come back. So very difficult to locate the measures. And because there is one reason. Another reason is their characteristics may be very different from the rest of the population. Say, for example, we have a migrant population that are coming from Myanmar to Thailand to work. So their characteristics are very different than the local resident. So we can just take the census in Myanmar and then miss out the whole population of Myanmar migrant population in Thailand. So census, these are the first reason. Say there is a study called, they said that illegal immigrants reluctant to fill out census form because they are afraid that the authority may use their data to inform the immigrants. So they are reluctant to fill out census form. And second, population rarely stands there. Like I said, we travel constantly. And another one to do census, not to do census is, it is expensive, everyone in the whole country. That is a big operation, logistically, financially, resources. You need a lot of resources to make it happen. So that's why we do like census every 4 or 5 years. Okay, so how do we make our sample so that our sample may represent the population we want? Okay, so this is a very good analogy from the course. So it's like stirring the pot. Okay, so you stir the pot, you are cooking the curry, and if you want to taste how the cooking goes, then you just take a tip the spoon and then just taste on that tip. You don't just drink the whole curry pot just to see whether it is good or not. So it's like something like that, sample. We also take sample like using the same idea. Okay, so we just take the sample that should be representative of the whole population. So that is the key word here, representative of the whole population. Okay, so we have the whole pot. So we just dip our spoon and then taste it and see how it goes. It is called exploratory data analysis. Okay, we are exploring the taste. And then second, okay, we taste it. Okay, it's good or it's not good. We need more salt. It's like we are trying to talk about the whole pot. So it's called inferencing to the whole population. Okay, so these two should be connected by the representative sample so that our data analysis should, we can draw conclusion about the population, about what we want using our sample. Okay. So here, we are doing research studies because we want to know about the population. We don't want to know about the sample, we want to know about the population. So that's why you can see that a lot of quantitative research papers include inferential statistics. So that's why these days we need the knowledge of both basics and inferential statistics to understand these papers, how they make the conclusion. So based on that kind of statistics, confidence interval, p-value, you may have of this terminology. So a lot of scientific papers, quantitative scientific papers, use these terminology a lot. Okay, so okay, we have population, we have sample, and the process how we get our sample is called, the process to get our sample is called sampling. Okay, so it's like the first one is a convenient sample, which are individuals who are very easily accessible and included in a sample. Say we want to know the COVID situation in Bhutan. So I will just ask you, the participant in this course. So this is a convenient sampling, because individuals who are participating in this conferencing, in this video call, may have a very different background, very different characteristics than those who who are living inside Bhutan. So using you guys may not be the representative sample for this example. And second source is a non-response, and this is commonly seen in surveys. So we approach a population and say, okay, we have this survey which will be very beneficial to the community. We would like to ask a few questions, say, and then they don't want to respond. So or they are not there at the community. Say, so last year we did a survey, a small survey in Thailand, and in that survey we have like 30% something non-response rate. So it's like 3 out of 10 people do not respond to our survey. So it's like those who do not respond to our survey may have a very completely different background than those who respond. This is called non-response bias. But if you, here is, we use a randomly sample people. So if only a non-random fraction of randomly sample people respond to a survey, so we still have the randomly sample proportion here. So next is our voluntary response, which is like the people who volunteer to respond, maybe because they have strong opinions on the issue, right? So it's like we are using Facebook these days or social medias. Like people see your post and then they try to write a comment or they try to say something about it, just because they have strong opinion on the issue. Otherwise, we will just scroll down and then skip it, right? So this is called voluntary response. So a lot of people see their post responded in a negative ways. That means that the people in majority are not, they don't represent the majority of the people. They just have strong opinions on the issue. They are just a minority. These are called a voluntary response, okay? So here's some quick example, like show the was interview in Syria, yes or no, vote. And then they say that, okay, should the result is 34% yes and 66% no. And total vote is coming from 1,500 people. And say this is not a scientific vote. You see, this is just a voluntary response. So it may not represent the whole population. Okay, so I have a few questions because I have talking a little bit longer. So say that a retail store considering updates to their credit card policy randomly samples 1,000 of their credit card holders to survey on the phone. So they use the phone to survey them. And the phone calls are made during business hours. Therefore, there is a low rate of response. So you see there is a non-response rate from members who work during these hours. So what type of bias is this indicative for?
Non-response.
Yeah.
Looks like non.
So everyone agree?
Non-response.
Yes, yes. Okay, so it is a non-response bias. So here's a few more examples. Okay, here's a few more examples. So this is coming back from 1936, which I believe nano Fs were here at the time, right? So these are this is from US, between the two big parties in US. So from the Republican side, London was leading, and from Democratic parties, FDR is leading. And so this is Roosevelt, right? And so what the newspaper, the Literary Digest did is they took, they surveyed 2.4 million people. That is a lot of people, right? 2.4 million people. And then here's the result. They say that FDR will lose with 43% of the vote. Okay, so FDR Roosevelt will lose 43% of the vote. That is the result from the very big survey done by the Literary Digest. But the election results came with 62% of the vote on FDR, because at the time they just used the telephone surveys to the subscriber or who has been subscribed. So the subscriber has a different characteristic background. Those who does not subscribe the Literary Digest, and those who subscribe, those who read the paper of the Literary Digest have a very different opinion on Langdon, the Republican side. So that's why they come up with a very different result, right? 43 to 62. So that is almost 20% difference of the result. So it just means that no matter how large your populations, your number is, it doesn't matter. All you need is you just have to make sure that your sample is representative of the population. Okay, so here I will talk about a few more sampling method, how to make sure that we got the representative sample. Okay, the first one is simple random sample. This is very easy to do, right? It's like the lottery. You know lottery? So
yeah,
you have a long list. Okay, say I want to make a random sample of the people here in this group, around 30 people. So what I have to do is I have to come up with a name of everyone, or with a way to identify everyone. So I have a list, 30 people, 30 individual, and then I just make a, tossing coin or just pick some random number. This is called simple random sample. But of course, you have to know the whole population, right? This is called line listing. You have to know the line listing. Otherwise, this cannot be done, because the random generation cannot be generated. So this is useful when you have a cohort. And then you want to randomly select everyone. Say in your clinic, you have a patient list of patients, and you want to randomly select those patients. So this is very useful in that kind of situation. But it's very bad in doing it in survey. Okay, so you want to do a survey in a school, and that is possible because you have a list of students, every student in the school. But in a situation where you can get access to this list, it won't be possible to do this random sampling. The next one is stratified sample. Okay, so basically what we do is we divide it into groups and try to collect randomly from each group. Okay, that group is called strata. For example, say we have in this group, 30 people group, we have male and female, and we want to look at, say, okay, the prevalence of drinking alcohol, okay? And we want to see the prevalence of drinking alcohol among male and among female. We want to get the same sample size. So what we can do is we can stratify based on the based on the sex or gender variable. So we have male group and we have female group, and then we did a survey, randomly sample on this two group. Another one is cluster. So before we go to cluster, stratify what kind of variable we can use as a stratifying variable, right? So we can use characteristics of people, of individuals, or of things, micro. So we can use the characteristics, say age group, sex, marital status, we can stratify on them. But on cluster, it goes on a bigger scale. It goes on the geographical scale. Like, say we have a rural and urban area in different, say in 8 cities. So we can create cluster based on the geographical region on the rural and urban area, on 8 cities as a cluster, and then stratify on the rural and urban area. So commonly, this cluster sampling method is commonly used, like multistage. We call multistage sampling method. So say we want to look at the prevalence of smoking in Bhutan. Okay, so the population is everyone in Bhutan, and then our sample, where we say we cannot do the census because it would be too expensive. So we will just do 3 major cities, say, and then we can create a cluster. First, how do we select these 3 cities out of all cities in Bhutan? So that is the first stage. Then when we got the 3 cluster out of these, and then we can define our strata based on age group, because age group can also be associated with the smoking. So we can stratify age group and to make sure that everyone in each age group include in our study sufficiently. And then for each strata and each cluster, we randomly sample to assess the prevalence of smoking in Bhutan. So this is an example of using multi-stage sampling methods. Okay, so this slide illustrates what I've just said. So we have a lot of cluster here, cluster 9 cluster, and then we take 3, 4, and 8 cluster, and then we can even sample. We can even stratify, or we can just randomly sample the cluster. So it depends on your research questions and how many resources do you have, or what kind of budget do you have, or what kind of resources essentially do you have. Okay, so any questions?
Dr. Min.
Yes.
There is something about sampling fraction. Which sampling method does it fall?
Sampling fraction?
Yeah, something like that, which I've learned before, but I'm not quite sure where it where it is?
I
Is it
have
in
not heard of the name. So can you give an example, like how do we use this sampling fraction?
It's something like to get the representative sample. Is it? I think it's in the in the simple random sampling, or
I think
there's
what you're
something called
referring is sampling weights, right?
there's this term sampling fraction. I was just wondering if you
And
could
I'm
shed light.
afraid I don't know.
Okay.
Okay. Anybody from this group know? Anyone? Sampling fraction.
Hi, this is
Yeah,
Tinley.
Stanley. Yes.
I believe that Chawang is asking about the sampling fraction, where in simple random sampling, when you line listed the population, for example, if there are 1,000, and then if you select 100 of them, then you take 100 by 1,000, and then you take the percentage.
Oh yes, yes.
That is called sampling weight.
Sampling weight.
I think okay, sampling weight is also a very broad term. Like I don't think that is used in simple random sampling. I think it's used in multistage sampling methods. So say you have this. I think we believe we did that in the study done by Kama Tenzing, Internet Edition. So what you are saying is out of 100, out of 1,000, you took 100, and then you divide 100 by 1,000. Oh, sorry, 1,000 by 100, right? And
Yes,
then you
yes,
got a
and then
fraction.
yes, we take that as the interval then.
Yes.
And
And
select that.
as far as I remember, I think that is used in the multi-stage sampling, so that you can derive, I mean, for the next stage, what kind of proportion are you, what kind of fraction are you going to take from each cluster? I think that is the purpose. Okay,
Right,
so right now I'm not sure, but I will read more about it and I will get with the response tomorrow.
Myung,
Yeah.
isn't that that we used for in systematic sampling? The fraction, sampling fraction?
No, systematic sampling is also different. I think the
Yes,
same.
it is different.
The same
It is
process,
different.
but it is used differently.
I mean,
Because in
to say
systematic sampling, which is not included in this slide, in systematic sampling, we want the K interval, right? So say we have 1,000, we want to take 100, and then you divided it, and then you have the 10 interval, right? 10 interval
yeah,
for every.
that is what I meant to say. The sampling
And that is not
fraction
simple random sampling.
in the term sampling fraction isn't that is the K that we used in systematic sampling?
Yes, I think it is the same process. Yeah. Who is the one who asked a question? Can you repeat it again? So is it used in simple random process, right? Simple random sampling.
Actually, I wasn't quite sure where it's being used, but just had this term before, and I was wondering where it fits in your slides. So I was asking.
Okay. Thank you very much for the question. Yeah.
Hi guys. Actually, there are two ways to interpret the sampling fraction. It's used sometimes in the sampling method only, and then it can also be used to calculate the weights. Especially in simple random sampling, when you take, so what some of the books say is that your sampling fraction, the fraction out of the fraction out of which the fraction from the population should be at least minimum of 10%. So some books usually say that your sampling fraction, the sample divided by the population, should be greater than or equal to 10. But when you go for multi-stage cluster sampling, and then when you calculate the weights during analysis, this is also being taken into account. So I'm also not sure, maybe there's more to read into it.
Yeah, thank you very much, Tinley. I think it explains. So we can use both in both scenario, right? And as a sampling weights and as a in designing our sampling process. Any questions? So, do you want to continue or stop here? What do the majority think in this group? Or the majorities are asleep?
I think it's okay to continue.
Continue for another 15 minutes, sir.
Okay, so I think we will just continue, and if you have anything to do, just drop out. Okay, this is like a non-formal situation, so feel free to drop out if you just have to do something. Okay, so let's continue with the experiments. So I think this what we are trying to talk about in this course is we just only want to cover the basic concepts that we want to carry to the statistics with R. Not necessarily discuss about the sampling and sampling methods and all these things. Just cover, just touch the topics. Okay, so and to say that let's take this opportunity as a learning experiment. Like, I'm not giving you a lecture, or I'm not. It's not that I am giving you a lecture or anything. Just we want to learn all these things together, and so that our knowledge will be much more than what we had before. Okay, so don't take it seriously as a lecture. And okay, so we will talk about the overall principle of the experimental design. So what makes an experimental design? First one, control. Okay, so you may heard about the previously we talked about observation and control in the other slide. We have two groups always, control and also the treatment group. But that is not necessarily the case. So some study will only have the treatment groups without control. That can also happen. So that kind of study, in that kind of study, they usually coin the term quasi-experimental study or something like that. So you will see a lot of this kind of terminology, which you should remember that these are not complete. Quasi-experimental design, these are not complete. So in order to have a complete feature or complete principles or experimental design, we should have the first one, control. So we have to compare treatment of interest to the control group. Second, randomize. Okay, so this is also very important. So there is some study without randomization. So obviously in observational study, there is no randomization. But in also experimental study, we cannot randomize. So in that case, this is commonly because due to the ethical reason and due to the disease, we cannot, in that case, we cannot just randomize these subjects. But but in a typical experimental design, we should have randomized control, randomization. And the third principle is replicate. So it should collect a sufficiently large sample, and so that we can replicate the entire study and get the same result. Okay, so can someone stop doing that? I think someone is annotating. Okay, so to the next, the fourth point, we have blocking. So one of the advantages of using experimental design is you can block for variable, known variable effects. Okay, so if you know that this variable can be confounding the relationship between the exposure interest and the outcome, and then you can block for the variable. Say for example, sex. Okay, so such gender variable is a known variable, is a known confounder in your study, and then you can consider gender variable when you design your study. So this is called blocking. So basically this blocking is to control the effect of confounding. So which is not there in observational study. In observational study, you cannot just do that. So we got the complete control over, not complete control, we have some control over the confounding variables we can use in experimental design. So you have to remember these 4 principles. The first one, you have to have a control to compare for comparison. Second, you need randomization. Every assigned subject should be randomly to the treatment and control group. And the third one is when you replicate study, you should get the same result. And also it means that you should have sufficient power to make the conclusion. And the fourth one is you can block the known confounder variable. Okay, so let's try to do a mental exercise. Okay, we want to design an experimental study. Looking at whether energy gels have you run faster. Okay, so when you run a marathon, you drink energy gels. So is it really effective? Does it really help you run faster? So we have two groups, right? The first one is taking energy gel, and the second one is control group. Okay, so okay, let's say we will do a experimental study with our current participant. Okay, we have around 30 patients, or actually 48 patients, or 40 participants. Okay, so I will divide into 24 groups, and 2 groups, 24 each, and then we'll assign group A to take treatment means energy gel, and we will assign treatment group B with no energy gel, and then we'll ask them to run a marathon. Okay, or even 5K run. Okay, so what do you think affects the energy gel? So if you have a lot of, if you run regularly before, or if you are a professional runner, professional athlete, then taking energy gels or not taking energy gel might not be that different, because you will always run faster than amateur athletes, right? Beginners. So we know that this will confound our result. So we will block the status of professional. Okay, so we will block the status of professional and divide the sample into pro and amateur, beginner. Okay, and then we will randomly assign. So this is a strata. Okay, we have 2 strata, pro and amateur, and then we will so we have pro and amateur, and we will randomly assign pro and amateur athletes so that they will be uniformly presented in our treatment and control groups. And then we do the analysis, and then when we draw the conclusion, we can say that whatever the result, the groups are equally, the pro and amateur athletes are equally representative, so this is no longer confounded by professional status. And then whatever the results say, the energy gels might work, so energy gels, one blocking the professional status, energy gels really works, something like that. So this is an experimental design, but it has some limitation, because you can do, sometimes you can just randomly assign the treatment group, because it's not ethical, right? So smoking, say, I cannot randomly assign you to smoke, because it's unethical, right? It's not, it's harmful to your health. So the same way, when you look at the outcome being dead or alive, it's not, there's no way to randomly assign it or something. So this is the experimental design. And then blocking versus explanatory variable. So usually explanatory variables are your variable of interest. And blocking is the confounding variable we know for sure, right? And then we will block these variables so that their effects may not implicate our conclusion, our result. So you can say that here, you can say that blocking is like stratifying, and then you make a random assignments to get the two strata. In our case, the professional and beginner, we want to uniformly represent it in each group. So we block using random assignment, and then we stratify random sampling. So some terminology before we proceed, there are placebo, which is effect treatment for control group, and placebo effects, which is showing changes despite the placebo taking the placebo. And then there are some blinding, which means, which I've been saying that this does not cover the complete lecture, series on the study designing the studies, but just touch on the concept. So blinding is that we don't know which group they are. So as a researcher, we don't know which group they are. So there should not be bias coming from the researcher. And there is also that single blind, double blind, and even triple blind for the blinding process. And for the double blind, experimental unit and researcher don't know the group assignment. Okay, so single blind is the patient, the control group and treatment group, they don't know which group they are in, but the researcher know. In double blind, both the patients and the researcher don't know. So that is a triple blind. So in that case, the patients, the researcher, and even the data coder, data entry, or even the data analyst, they don't know which groups the patients are in. So the last session, random sample assignment. So we talk about random. So how do we do the random sample assignment? So we got the population, and then we got, we will take some people out of this population. It is called random sampling. What is random assignment? So we got a sample. Now, from this sample, we will, randomly assign to the treatment and control group. So that may indicate the causality. Okay, so random sampling is taking the sample from the population, and random assignment is assigning the sample in two groups. Okay, so let's give you the final example today. So there is a serif font and sans serif font. So which you can see that it's serif font has some decoration at the end, and sans serif font is very straightforward. So what we want to know is we want to know if you use serif font, people read faster, or if you use sans serif font, people read faster. So we want to know the comparison between serif and sans serif font. So the population, we will take the random sample, that is called random sampling, and then from the sample, we're assigned into two groups, randomly assigned to two groups. Those we will make them read books printed in serif and read book. The other group reads in sans serif font. And then we want to also look at the fluency, right? So if they are fluent reader, and then no matter how what kind of fonts they read, they will read faster, or how often they read for leisure. So these will improve the general reading speed, regardless of the font type we use. So we want to also block these confounding variables. So this is how you design a study. So first, random sampling occur, and second, random assignment occur. Okay, so what if we look at the random sampling and random assignment in the 2x2 matrix? Okay, so the first one, we have random sampling, which is good. And now we have random sampling, which is for experimental. So this is causal and generalized area, ideal for an experiment. Okay, so the next column, we have non-random assignment. So we randomly selected, but we don't randomly assign. So it just means we observe these patients. So this is what our most observational studies come in. The next row, we have non-random sampling. So we don't do random sampling, but we have random assignment. Okay, so for experiment, we have a few patients, we have a few number. So cannot say usually we cannot do the random sampling, but we do the random assignment, which makes our study look at the causal connection. So that's why causal, but we don't do random sampling, so that's not generalizable. So the last one is very bad, right? No random sampling, no random assignment. So our most observational study falls on the random sampling but no assignment, and our most experiment comes on random assignment but no random sampling. Okay, so I think that concludes the today, and then for